All right, problem number 3. Find the given trigonometric functions for each of the following triangles. Simplify your answers, but leave an exact form. Okay, so a couple of things that we have to know for this problem is, first of all, the Pythagorean theorem. Pythagorean theorem. And essentially, the Pythagorean theorem says that if you have a right triangle, so you have a 90-degree angle in that triangle, and okay, so we said the hypotenuse is, let's label that C. The hypotenuse we said is always opposite the 90-degree angle. And the other two side lengths are called legs. So we'll call one of the legs of length A and the other length B. The Pythagorean theorem says that if you square the legs and add those together, that is equal to the square of the hypotenuse. So in problem number 3A, we have a right triangle. And so if we call this leg A, or B, whatever variable you want to use, then the leg squared plus the other leg squared equals the hypotenuse squared. We can solve for the length of that missing leg. So 16 plus A squared equals 36. If we subtract 16 on both sides, then we get 20. And if we want to solve for A, we can take the square root of both sides. And A is equal to, well, the square root of 20 is the square root of 4 times the square root of 5. So the square root of 4 is 2. So we can simplify this to 2 radical 5. So that's the length of, and officially we actually should have a plus or minus sign, but when we're talking about lengths of sides of a triangle, we only consider positive lengths. So I neglected that negative. All right, so now all we have to do is look at the angle that we're talking about, theta, and we're asked for the sine of theta. In the previous problem, we said sine was equal to the opposite side length divided by the hypotenuse, right? So this triangle is flipped around compared to the one over here, but the opposite side length is still the one opposite the angle marked theta, and then the hypotenuse is always the length that is opposite the 90-degree angle. So our answer is going to be opposite side length divided by the hypotenuse length. Next, we can do the secant of theta. That is the reciprocal of cosine. So if the cosine of theta is adjacent over hypotenuse, then the secant of theta will be the reciprocal of that, 6 over 4, and that can be reduced to 3 over 2. Nice and easy. And then finally, the tangent of theta. The tangent of theta is, TOA is opposite over adjacent. Opposite over adjacent. Now we can cancel a 2 there. So that is the root 5 over 2. And that is 3a. We'll do 3b, I guess, just to look at it real quickly. We probably won't do all of the problems, but we'll do a few of them. So 3b, we want to find the length of this missing leg. I'm going to call it a again. A squared plus b squared equals c squared. Okay, so leg squared plus leg squared equals hypotenuse squared. We subtract 9 on both sides, we get 16. And then if we take the square root of both sides, we only care about the positive square root, so that would be 4. This is actually a pretty common right triangle, the 3, 4, 5 right triangle. So now the cosine of theta, notice where the angle is that we're looking at. That is the angle there marked in black. Cosine is adjacent over hypotenuse. So 4 over 5. Cosecant is the reciprocal of sine. Sine is opposite over hypotenuse. So cosecant is hypotenuse over opposite. 5 over 3. And then finally cotangent. Cotangent is not opposite over adjacent, but adjacent over opposite. Adjacent over opposite. All right. So that's pretty, pretty quick, not too complicated. Next, we will look at problem number 4.